I am Mark Stahl with Work in America. Workin is the worldwide leader in manufacturing recycling equipment. Going to continue on with the full depth reclamation topic, but what my specific topic is going to be is the equipment. Going to go through the train of equipment, talk about each individual piece, talk about the process in general, and then talk about some construction techniques that can be incorporated to make sure that the project is successful. Obviously, with full depth reclamation, we're reclaiming or using those valuable materials that are in the road. Typically, you have three different sections of a roadway, cross sections. You have the asphalt layer or the chip slurry. You have the aggregate or the cement-treated base, and then you have the soils. What we're talking about is the top two. We do not want to get down into the soils. Anytime you do full depth, it's greater than 6 inches. That's pretty self-explanatory. We've seen 10, 12 inches as the normal. So what we're doing is we're getting through the asphalt layer into the aggregate and going at a consistent depth. This is a typical candidate for FDR. It is a road that is failed. You have alligator cracking. You have rutting in the wheel pass. Water obviously gets through the pavement down in and creates havoc. So this is a perfect candidate for an FDR project. Typically what we see, there's three different applications for FDR. You have the FDR with cement, which in this part of the country, 80 to 90% is with cement. You have reclamation with emulsion, and then you have reclamation with foam bitumen. We will concentrate most of the talk today on the cement. So what are the weather restrictions? Obviously what VDOT says is, and it's true, you need the ambient temperature to be greater than 40%, but more importantly, you need the pavement materials, the materials in the roadway, to be above 40 degrees. Otherwise, the reaction times are slower, and it'll take a longer time to open it up to traffic. And then obviously we want no rain in the forecast. The last thing we need is a deluge of rain come in and mess with our process. So I want to break down the process a little bit and do it in segments. So the first thing we're going to do is close the area to traffic. Then we're going to go in and pulverize with the reclaimer. We're going to go in and downsize the material, mix the asphalt surface with the aggregate base. Then you're going to apply the addition of the additives, whether it be cement. Mix all that material together. So you're going to bring the reclaimer back, make a second pass, mix the additives with the present material along with adding the water. You're going to place it, so the blade's going to put it on grade, hit your lines that you need to hit, and then the compaction is next. So all that material is compacted. We apply the fog seal, and then at the end of the day, we open it up back up to traffic. And then there's a curing period, and Dave mentioned that the next day you're putting aggregate down. Sometimes it waits. You can wait 3 to 4 days. It depends on the moisture content and the surface that you're putting back on top of it. And then the wear course, which I just described. It could be asphalt, chip seal, but the main thing to keep in mind with FDR, with cement, with bitumen, is it is not a final wearing course. It needs to be sealed. So another course has to go on top of it. Okay, talk a little bit about job site logistics. Main thing to keep in mind is it's typically done under traffic. There's very few road owners out there that'll let you shut down the entire road. That would be ideal, of course, but typically traffic needs to get around you. So you got to block off one lane with flaggers or a situation with that. Plan on the center line being from center line to the curb is your working area. And then the length is determined by the application rate of the additives. So based on the design, how far will a load of cement go? And that is typically the length of the segment. It was brought up earlier that you can do typically 1.5 miles of FDR a day. Well, your segments are going to be closer to 1,000 or 1,500 foot based on the application rate of your cement. So you're going to do these segments throughout the day. Okay? So you're looking at how far an additive load will go, a cement load, and then you're also looking at what's the distance that blade operator can finish. Because we have time constraints with the time we put the cement on the ground till it's compacted and basically put to bed. 2-hour window is typically what it is. So you need, by the time you put the cement down and then you process it and put it on grade, you have to have a short working window. I'm a big fan with mixed designs. You know, you can talk to the road owner, you can talk to the designer, and everything is supposed to be consistent. But what you'll find is periodically you'll find parts that aren't, and that's hopefully the process the design will factor in. Is the materials change throughout the road, and it's really important to understand what's there, so you can react when you're constructing it. So the design is always a benchmark, and it's important to have the appropriate equipment on the job site to achieve that design or that construction plan. Okay? So we had talked about a 12-foot lane. This side is open to traffic, and this is the working lane that you're going to be processing. You have a 12-foot wide road, but typically your cement spreader and your reclaimer is 8 foot wide. So that presents a little bit of a problem. You have to think about the logistics involved with this. So I see typically that the contractors will go center line in. So they'll spread the cement 8 foot wide, and then they'll take the reclaimer through and process 8 foot wide. So let's say the length is that 1,000 foot that I mentioned earlier. They'll go down to 1,000 foot. They'll back the machines up, and they'll take a second pass. Okay? Second pass looks like this. This 8 foot's already been processed. So when he starts the second pass, hopefully you have a variable width spreader, and you can put 4 foot of cement down on that second pass. The reclaimer is 8 foot. You can't change the width of that. But what you can do is you can change the width of the injection of the water and only do 4 foot there. So this 8 foot pass will be processed with only 4 foot of cement, 4 foot of water, and that 12 foot lane will be complete at that time as far as processing goes. At this point, after the second pass with the reclaimer, the blade can get on the project or this segment and put everything on grade. So that's typically how you see the lanes progress when you're on an FDR project. Here's a picture of a half width spread of cement. So this is a 8 foot wide machine. It can put down 8 foot down to 4 foot. And then this is a picture of the injection system in our reclaimer. It shows the nozzles. So you can shut half of these off, and instead of going the 7.9 feet, you can go 4 foot. Really important not to overdose with cement or bitumen or water. The last thing you want to do is overdose. Create soft spots and you have a problem. Okay, I'm going to show a video, just a animation that shows the equipment train.
For cold recycling with pre-spread cement to produce a hydraulically bound base layer, a Streumaster binding agent spreader pre-spreads a layer of cement. Computer-controlled metering feeders guarantee highest spreading accuracy, regardless of the spreader's travel speed. Next follows a water tanker truck. The recycler draws in water via a hose connection. The recycler is equipped with a push bar to push the water tanker truck along. The powerful milling and mixing rotor granulates the damaged pavement layers. The pre-spread cement is mixed in at the same time, and the required amount of water is injected into the mixing chamber via a microprocessor-controlled injection bar. A Ham single-drum compactor with smooth drum compacts the recycled homogeneous construction material, while a grader carries out finish grading. A tandem roller and a pneumatic tired roller complete the compaction process to produce a uniform, sealed surface structure. The highly stable layer provides an ideal base for construction of the upper pavement layers.
So this is, of course, FDR with cement. So we're typically between 4 and 6% cement with this application. The next application is FDR with cement and foam bitumen. With foam, you need a minimal amount of cement. So you're talking about 1% spread rate as opposed to 5 or 6. So maybe a half of an inch spread of cement in front of the reclaimer. So the difference here is just the equipment train adding the bitumen tanker.
For cold recycling with pre-spread cement and foamed bitumen, a Streumaster binding agent spreader pre-spreads small amounts of cement. Computer-controlled metering feeders ensure high spreading accuracy. Behind the spreader, a water and a bitumen tanker truck. The Wirtgen recycler draws in the binding agents via hose connections. The recycler is equipped with push bars to push the 2 tanker trucks along. The powerful milling and mixing rotor granulates the damaged pavement layers. The pre-spread cement is mixed in at the same time. A special injection bar with expansion chambers produces the foamed bitumen and sprays it in. Water added to the process causes the bitumen to foam abruptly, expanding it to many times its original volume and distributing it evenly in the mineral aggregate mix. At the same time, the amount of water required for the mixing process is added via a second injection bar. Compaction is effected by Hamm single drum compactors, one with a padfoot drum followed by a second one with a smooth drum. Next comes a grader for finish grading. A tandem roller and a pneumatic tired roller complete the compaction process to produce a uniform sealed surface structure.
So you can see this process is real equipment intensive. Big long train of equipment. As we talked in the safety segment, a lot of moving parts here. Have to make sure everybody's on the same page in terms of where people are, where equipment pieces are. So the coordination here is very important. But when you talk about the train, you've got the cement spreader out front, then the water truck, the bitumen if you're using either emulsion or foam. You've got the reclaimer, padfoot roller blade, the 2 rollers following, and then you have the distributor for the fog seal. So a lot of different pieces all lined up together, working in concert with each other. So I want to break this process down a little bit and talk about what the specs call for. So the first machine out front would be the cement spreader, and in the VDOT construction methods, requires the additive to be spread uniformly, both length and width. Need to be applied with a calibrated automatic meter. And then the application range that they allow is 0.2 of a percentage point. So if your mix design is 5%, you can be at 4.8 up to 5.2. So pretty short range to be able to hit. This is a video of a non-metered spreader. This did not take place in the state of Virginia. So majority of that's up in the air right now instead of being on the road. But you can see the real inconsistent spreading rate there. Basically, they open the valves up and then the driver drives and he just puts it on the ground. And if he gets to the point where he's supposed to be empty and he's not empty, he just backs up and makes another pass. You can see the wheel ruts there. If he gets stuck, if it gets stuck, he just keeps spreading. You can't shut it off from the cab. So you can see a lot of people filming this because it blows people's mind. So you can see the width, you can see the light spots, you can see the heavy spots, and it goes throughout the road. So you end up processing that with a reclaimer, add water to it. You're going to get areas that are too highly concentrated, it's going to crack, or you're going to get areas that don't have any cement in it and it's going to fail because it's soft. So the consistency is important. Here's a picture of the start stops, and then at one point on this project we had an 18-inch lift of cement sitting there. So there's no way that the reclaimer can go in, mix that uniformly in the existing materials and hope that that's going to last. Of course, this is extreme, but this is what we tend to see. Here's some other different techniques that people get around from having a qualified spreader on the job. This is that same type of transport unit. It's got a material bung coming off, and they've made a 24-inch shoe that they drag down the road. And they pump the cement into that shoe because they want it concentrated in the middle. Tends to work for them, but that is in a different state. This material box here on wheels is a little bit better. He's got a screw gate there that adjusts the back material gate. So that is an adjustable material machine, but it's dragged down the road. We see a contractor used cement out of a stockpile, brought out an end loader, feathered it on the road, and where he was a little bit heavy, had the labor come back with a broom and smooth it around. And then lastly, where we see a lot around other parts of the world is in bags. Real labor intensive. They spread the bags out, and then they just have the reclaimer go through and chew that through that. So if they don't have the means to have a spreader, bags is a good method, but look at the equipment on site. Obviously, they've got the means to have a spreader there. So these are different techniques that don't work, that typically give you poor results. We want to avoid that. Execution points with the cement spreading process. Keep in mind that you only want to go as far as you can in front of the reclaimer. If you go too far, so say you do a 1,000 foot area, and the cement spreader gets in and goes and spreads that 1,000 foot long, what happens is traffic's going to continue to drive up and down on the lane next to you. It's going to create a dust storm. Some of that cement's not going to be there when the reclaimer gets there. What happens if a rainstorm comes in? All that cement's washed to the edge of the road. And lastly, and this never happens with the contractors in Virginia, but sometimes the machines break down. And if the machine has to stop for the day, you've got to sweep all that cement off the road before you can open it up to traffic. So what I typically tell the spreader guy is just go 200 foot in front of the reclaimer and stop. Wait for him to catch up to you, take off again. So very important. And then check yields on the first load of the day, every day. Check the application rate of the spreader. Put your 3 foot by 3 foot mat down. Check to make sure you're within the range. And then also figure out how far that first tanker should go. How many square yards should be covered with that first tanker, and make sure it's pretty close. So there's two different ways to kind of do a yield check. The next process is adding the water. So the VDOT specs call for the water content to be monitored closely to make sure you're within plus or minus 2% of optimum. Optimum, of course, is going to be on the design. So let's say that optimum is 6%, and that might be a little bit low. Let's go 8%. And the in situ moisture in the road is 4, then we're going to be adding close to 4%. We always want to stay a little bit less than optimum, so we're probably going to be close to adding 3% to get us up to 7, and then we'll adjust as we process the road. What's important is you have information to understand how much moisture is in that material. So you can use a newt gauge, or you can do the old method of taking samples, drying it down, and figure out the weight difference. But that's important. We'll see in a little bit, there's some methods that you can do to check it, grabbing a sample as you're going down the road. But this is really important. We need to know exactly where that moisture content is, because like Dave described earlier, if the moisture levels aren't right, then your process isn't going to be right. This is a picture, two extremes. One, you have a water truck that's putting just a little bit amount of water on. This would be a good technique for in between the blade and the rollers. And then you have the other extreme to the right of absolute flood. Water's running into the ditch at this point. So if you use this method to have water in the processing, you're not going to be accurate. There's no way you can be accurate. That's why we adamantly suggest injecting the water into the reclaimer. This is a picture where they're putting the water on top, they're trying to guess the amount of water that they're adding. The cement is already spread, and our reclaimer is going through. But there's so much water that it's leaching into the adjacent lane that has already been processed. And losing the water out from under here is bad enough, but it also takes the cement with it. So in this situation, your dosage for cement and water is not going to be accurate. Again, water injection is so critical. You can if you understand the mix design of the optimum water percentage, you know how much water is in the ground. If you're able to inject the water, you can dial in that percentage, and it'll be consistent all day long. Plus, it's putting the water exactly where you need it to be, in the mixing drum. This shows the injection system in the cab. So our rotor is 8 foot wide. We have 16 injectors in the drum housing. It's microprocess controlled, very precise. You just input the amount of water percentage. So in this situation, we're putting 1.8% water in based on mass. And what's nice about this system is you're able to shut nozzles off. So by turning these 4 off, you could minimize your water input to 4 foot. Comes in real handy when you're doing those overlap lanes that I talked about. There's a picture of the reclaimer pushing a semi-truck. So this RWRs have enough horsepower to push a semi and a water truck in front of that. If this was a bitumen tanker, it would be next to the reclaimer. The water truck would be out front. So it's able to push those trucks, pump the water into the drum, and continue down the road. Some things about the water, some execution points. Obviously, if the injection system is an option, use it. Eliminate spills at the end of the load. This is critical because going back to the previous picture, you can see hooked up, we have about a 15-foot water hose, 3-inch, 4-inch typically. When that tanker is empty, he's going to unhook, drive down the road, and the new one's going to back up. But typically what the worker does is they'll unhook that, and they'll drop that water hose right on the ground. So the 20 to 30 gallons of water that's in that hose sits right there, ponds right there. New truck backs up, you hook back up, recycler's going to start injecting water again in that process. So what you've done is you've oversaturated that area where you dump that hose. And we've seen projects in the past where that is done consistently, and you can go right down the road and figure out where that failure is at because you can see it. So it's important to make little notes and little improvements. Instead of dumping that hose right on the ground on the pavement, have that labor walk over 4 or 5 feet and put it in the ditch and let it drain out that way. Nothing hurt by having that water in the ditch. And then make sure the water doesn't have contaminants in it. If you go suck from a pond or a creek, you're going to get algae, you're going to get contaminants in it that's just going to plug up your injectors. Make sure it's clean water. Here's a picture of inaccurate water delivery. Now this is not the FDR process, but it shows our cold-in-place recycle machine along with a bitumen tanker and then 2 water trucks out front. So you have a very large, long water line. So those leaks aren't too bad, but they get worse the farther down the pipeline they go. So when you have hoses leaking like this, even if you know what your optimum moisture content is and you have it dialed in to be injected correctly, who knows how much water is getting added in a situation like this. But I thought this is more comical than anything, how much water is being dumped on the ground. The bitumen tanker would be next if you're using foam or emulsion. So that would be right in front of the recycler, or the reclaimer, I should say. You can see the push bar there with the pintle hook hitch on the back of the semi. And then you have the the material port with a gate valve. And emulsion is typically delivered to the job site about 100 degrees. The maximum is 120, so it could be anywhere from 80 to 100 degrees. So that material is not so risky. But when you're dealing with foam's delivered on site at 320. You need hot liquid asphalt for the foam process to work correctly. So it's delivered hot, and we really have to pay attention to the risks involved with that. So this hose needs to be a heat-rated hose that can handle 320-degree liquid flowing through it all day long. And then the PPE of the people there need to have definitely long sleeves, a face shield, and gloves. So I can't stress enough how important this is. Really, in the foam process, this is about the only risk involved is the hook and unhook of that material hose from the tanker to the recycler. Once the hoses are locked in, the reclaimer takes that material and puts it into the mixing drum. When material comes out the back, you can grab it. It's cooled down to ambient temperature. So really, the only risk involved is that hook and unhook of that material hose out front. That's a picture of our 250 reclaimer. And other manufacturers, recyclers. The most important part of that reclaimer is the rotor drum. This is the part of the machine that downsizes the road, mixes it thoroughly. When you come back the second pass, you're mixing the additives, whether it be lime or cement. It's adding the water. Everything takes place with this. So the number of tools is important, the quality of the construction of that rotor is important, and the revolutions per minute is important. With our machine, we have variable speeds that can be adjusted from the cab, and depending on how fast the forward speed is of that machine dictates what the RPMs are. Really, the only way to control gradation is adjusting the forward speed of the machine. Once you have the RPM set. So we'll talk about checking out the material behind the reclaimer in just a bit, but really the forward speed is going to dictate your gradations. So when we talk about the mixing of material, VDOT says that some of the specs, you have to have the ability to pulverize and achieve 100% passing a 2-inch sieve. So it has to be a 2-inch minus. Okay, that's typical across the country. And then the equipment has to be able to set a depth and be consistent with that depth. So if we have 4 inches of asphalt and 10 inches of aggregate, that's a 14-inch. We're probably going to set at 12 inches so we can stay out of the soil. The last thing you want to do is bring soil up into the pavement. So that's why it's important that your reclaimer can get set at a depth and be consistent throughout the project. This is a picture of what material looks like coming out of the back of the reclaimer when it's done correctly. We've got gradation. It's inside the spec of a 2-inch minus. You can see there's no oversized pieces. This might be the biggest, but it's mixed thoroughly. There's no additive chunks, no balls of cement there. It's all consistent color, and it's got proper moisture content. How I can tell that is by the imprint of the tires. And you also have a vertical face here with the impression. If it was dry, it would act like sand almost, where it kind of fall down on itself. Here's a picture of material that's not mixed well. See the gradation here? This would never pass. It's not consistent. You see pieces of balls of cement throughout this mat, and then the moisture level. This machine couldn't keep a consistent moisture level. The pump was high and low all day long and couldn't achieve the proper moisture limits. So this is what it looks like when it's mixing poorly. Execution, I can't stress this enough. Constantly perform moisture checks. That's why I put it up there twice. I'll show you how to do that in a second. Notice that the bitumen levels in your samples, your hand samples, make sure you can tell the difference between a dry and a emulsion job or a foam job that's got the proper amount of bitumen. Pay attention to the gradation. So you're constantly checking the sizes of the materials behind the machine. You can check the foam quality right there at the recycler. And just like we talked about with cement, you want to do your yield checks on the first load of the day. Figure out how long that bitumen tanker should go in terms of square yards. Put stakes in the ground, whatever you need to do, but know what area that should cover based on the mix design, and then make sure you hit that at the end of the load. The checks that I talk about, what you do is just grab a hand. It's pretty simple. You just grab a handful of material, make it into a ball, and it should ball up just like a snowball almost. And you will be able to break it if the moisture level is correct. Okay, so this would be an FDR with cement job. So really you're adding cement and water, and that's a good indicator that you have enough water on the project. You can also visually see the wheel ruts. So you have impressions. If this is a 12-inch job, you're going to have a good 6 inches of impressions here, and then you can see the straight up and down vertical face of that rut. Now what would it look like if it was oversaturated? Your hand would be wet. You would see moisture in the palm of your hand. Material would be like a mud ball, and you would notice a shine on top of the material here. So that's good looking material there. As far as the bitumen, same thing. Grab a hand, compact it in your hand, make sure it balls up. But when you get rid of all that, you should have little specks. This is a foam job. You should have little foam bubbles, the specks of foam bubbles in your hand. It's not going to be completely black, but it'll have remnants of the bitumen there in your hand. I talked about checking the quality of the foam. So I didn't cover foam in depth here, but basically what foam is, it's a physical process that takes place when the hot oil has a little bit of mist of water added to it. There's a violent reaction that happens. It's almost like taking a drop of water and putting it in a deep fat fryer, a deep oil fryer. Okay, it'll bubble up, and that's exactly what we're doing in the mixing chamber of our reclaimer. So what we need to do is make sure that this is reacting properly, that the oil's hot enough, that the water percentage is correct. So there is a test port on our reclaimer. You put a pail under there, and you inject foam into the pail. And what you're interested in is to see the expansion rate. The volume change should be greater than 10 times. Okay? So 10 times the volume change of that liquid asphalt. And then the half-life is the time it takes for that expansion to hit and then for it to get half that volume. So that's in the state spec. It has to do with, we need that expansion rate to happen so that in that mixing drum, as we're processing the material, that bitumen is spread throughout the material consistent. If this doesn't happen, our foam is not spread through our mixing drum, and you're going to have a poor product behind it. Next part of the process is the compaction. So immediately behind the reclaimer is a pad foot roller. 15 to 20 ton is what we typically see, and this is vital for project success. If we're going 12 inches deep, lots of rollers can get the top 4 to 6 inches compacted, but unless you have a pad foot of the correct weight, you're going to have a hard time getting compaction on that bottom lift. So the bottom, so at 11 and 12 inches deep, if you don't have the right size pad foot on the job, you're not going to get compaction on that bottom layer. Like I said, it's right behind the recycler, and we go for refusal density based on the growth curve. So once the rolling pattern is set with that for the day, it stays that way. Unless your additive amount changes or the moisture changes drastically, you'll keep the rolling pattern consistent. And that's kind of hard for the roller operator at times to understand, but you can't be doing his own thing. You have to be on the same page in terms of how many passes to make. Next comes the blade. And as we said, the blade waits until the second pass. So if you're doing 1,000 foot, the spreader and the reclaimer is going to go down 1,000 foot, do 8 foot wide, come back, do that second 8 foot pass, and then the blade can get on after that. Okay? That way he's got 12 foot to work, he can get his mow board set up correctly, and he can get the material on grade. The key is not to overwork, and the key is to keep moisture present. So you might have to have a second truck come behind and water that material to keep it moist. The last thing you want to do is dry that out. And then lastly, we have the two compaction equipment behind that. So you got the double drum vibratory, making it smooth. And then lastly, you bring the pneumatic, and that will provide for a smooth ride. Before the pneumatic hits it, we need to spray the surface with water in order to get kind of a slush roll. What that is that water, along with the pneumatic tires, will bring basically the fines to the top. When the roller is complete, that material will dry out, and it'll be a nice hard surface, so that cream will dry and it'll be hard. It allows it not to ravel when you open it up to traffic. So important for that pneumatic, when he's compacting, spray it with water right before, get that slush roll, and then let it dry out. So there's what a good finish looks like. Of course, we did the same thing. We went to the center line. You can see the moisture content is still present in the road. The blade took the material one way, brought it back a couple times, and then what you see is some like marbles, the larger material that rolls off the blade. You'll want to get that off the pavement. So what he's done is he put a windrow material up on the hard road, and what they'll do is they'll come back and pick that up either with a skidder or a loader bucket. It's just access that if you tried to put that larger aggregate into the mix, that's probably going to ravel off on you real quick after you open it up to traffic. So they've decided to put it off to the side, pick it up. The pad foot dipples are bladed out, so the blade has gone deep enough to get to the bottom of those pad foot marks. That's real important for a smooth ride as well. If you leave those in, you'll have rumble down the road, and you've probably seen it. And then the slush roll was completed with the pneumatic. You can tell the fines are incorporated into that mat. Should perform well. And then lastly, the fog seal. Real small amount, but that helps that cement cure slowly. It also helps with raveling, keeping the material together. This is what it looked like after it had been down a few days. You can see the fog seal is still present. You can see how tight it is. In fact, this was an area that the contractor had a high point on it. He took the blade, and you can see the shine that was produced after the blade went through to try to knock off a high point. Good results. They put a chip seal on it. It rode really well. The opposite of that, this is a job that had a poor finish. So what had happened is they let the material dry out during the finish. In fact, during this project, no water was added after the injection. So they didn't have a second water truck on it. So when they started blading, they didn't have water. When they did the pneumatic roll, they didn't have water. And what it did is it just made it too dry. You can see the pad foot marks are still in it. So the blade didn't go deep enough to take that out. So it was a rumble board driving down this road. Loose material. And the end result was a disaster. They chip sealed it a week later, and because that material wasn't kneaded together and tight, the chip seal attached itself to that loose material, and then when they opened it up to traffic, it stripped off. A lot of delamination. So they had to go back in, the contractor had to go back in and remove this, get down to areas that were tight before they could put a chip seal back on it. So I've given you some things to think about when the project is going on, some techniques to make sure we don't have situations like this, to make sure that our jobs are quality. Pre-construction meeting is very important, very vital for the contractor and the agency, the road owner, to sit down, talk about everything. Talk about the contractor's goals, how much they want to get done, the agency's expectations, make sure everybody's on the same page as far as the mix design goes. Talk about QC and QA testing, who's going to do it, who's going to share the results, what time of the day the results going to be expected to be done. Talk about the equipment train. You saw there's a lot of moving parts, a lot of things to think about. Do they have the proper compaction equipment? Is the reclaimer able to go at a consistent depth? Does the spreader meet specifications? Finalize the schedule, make sure everybody's on the same page, because when the job is going and is being executed, it's too late at that point. And then with Virginia specs, there's a trial section that's required, which I think is great. Get out there, go through the steps, make sure what they're going to do in the trial section is the quality that they're going to have for the entire project, and it gives everybody a chance to see it. Get on the same page before it starts.